We are starting Unit 2, so you need to make sure you have your Unit 2 note packet in front of you. Go ahead and open up to Lesson 2.1. It should be the very first note sheet. This is a review lesson, and it's one of my favorites. I enjoy those divisibility rules. Today, we're going to remind ourselves of those rules and also locate the greatest common factor between two numbers. Greatest common factor can be written as GCF. The goal for today says I can use the properties of divisibility to find factors of numbers. Something I think would be helpful as we move throughout this lesson would be if you have a calculator. So if you need to pause and get that calculator out, please do so. How do we know if a number is evenly divisible by another? You're going to see this question on the left-hand side of your notes. Well, let's start by talking about what does divisible mean. Divisible means when you divide one number by another, the answer or the result is a whole number. There's no remainder. There's no leftover pieces. Pause the video and write that down on the left-hand side of your notes under the question. Let's see divisibility in action. You don't need to write anything down right now. I'm going to take 117 and divide it by 3. If when I do that, my quotient is a whole number, that means 117 is divisible by 3. You can see on my calculator that the answer is 39. That is what divisibility means. When you divide, you get a whole number. No remainder. No little pieces left over. So you were reminded through words what divisibility is, and then you got to see it firsthand. Here's the other part. Now you will not see what I just clicked in. You're not going to see that on the left-hand side. I want you to write it down though. What are factors? You're going to hear that word used a lot today. Factors are the numbers you multiply together. An easy way to remember that is factors are few. Multiples are many. Multiples go on for forever, right? It's your skip counting. Those are your multiples. The factors are what you multiply together to get those multiples. So here's an example. 2 times 3 equals 6. 2 and 3 are factors of 6. Pause the video and write what you see on the left-hand side there. Also draw that example so that you can clearly see factors, because we tend to get factors and multiples mixed up. Pause the video. We're going to take a moment to check in. So you'll see that there are 3 arrows on the screen. Those 3 arrows are pointing to 3 different parts that you should have put in the left-hand side of your notes. If you didn't yet, pause and do that now. If you're ready, we're going to go ahead and refresh our mind on the divisibility rules for the factor 2, 3, 4, 5, 6, 9, and 10. You'll see you have a beautiful chart in your notes. There's a number column that is already filled out for you. There's a divisibility rule column. That is where you will write the rule and an example. So we're going to start with 2 and 3. You'll pause the video, you'll write the rule down, and you'll see that there's an example, and that example is highlighted for each factor. The example for 2 is in yellow, the example for 3 is in green. The example is nice because it's another way to see the rule. So pause the video. When you're ready, come back and you'll do the next 2 factors. Now we have 4 and 5. Pause. You will write the rule and the example. We're not quite done. We have 6 and 9. Go ahead and pause the video, write the rule and the example. Remember, those examples are highlighted. Take some time to think about them as well. Don't just try and finish this quickly. Take some time to refresh the mind. It's okay for it to take additional time. The last factor to refresh your mind when it comes to divisibility rules is the factor 10. And I must say, divisibility does rule. Thank you, Froggy on the bottom. Pause the video, put 10 in your notes. Find this part of your notes We are now going to practice applying some of those divisibility rules to help us determine factors of numbers so that we can find the GCF. GCF stands for greatest common factor, which we are looking for the largest factor two or more numbers share. Now you'll see in the directions I've highlighted 3 different pairs. In your notes, I believe it says a different number. We're just going to do 3 today. So we're going to find the greatest common factor of 3 different pairs of numbers. We're going to do that by showing our work. The first pair we're going to do is 12 and 16. Write that down. The second pair we're going to do is 48 and 72. And the last pair we are going to determine the GCF of is 35 and 63. So you will have 3 examples of finding the GCF within your notes. Let's get started with the first one. You have a beautiful chart within your notes that you are going to show your work. And your work is going to be the listing of factors to find the greatest common factor, the largest factor 2 or more numbers share. So our first pair is 12 and 16. We're going to start by listing the factors. And when I list factors, I like to see them in a T-chart or next to one another. And remember, factors are what we multiply together. So I'm thinking what times what gives me 12. And I like to go in number order. So I start with 1. 1 is a factor of every number. 1 times 12 gives me 12. So 1 and 12 are factors. Anything times 2? Yep. 2 times 6. And if you weren't sure about 2, you think, well, I'm going to use my divisibility rule. It's an even digit that is at the end of this number. So therefore, 2 goes into it. Anything times 3? Yep. 3 times 4. So 3 and 4 are factors. And if you're not sure, because sometimes 3 can be tricky, remember the divisibility rule. The number that you're looking at, add up the digits. So 1 plus 2. If it creates a multiple of 3, multiples are what you get when you multiply. They're the answer to multiplication problems. Then it's divisible by 3. 1 plus 2 is 3. 3 is a multiple of 3. We have divisibility. Anything times 4, that's just the next number that would go right here. Well, yeah, and you can see I already have 4 up here. So it's a repeat, we're done. Anytime we get a repeat of a factor when we're listing them, we're done. So let's go ahead and let's list the factors for 16 now. So we always know 1 is going to be a factor. 1 and 16, give me 16. Anything times 2? 2 and 8. Anything times 3? If you're not sure, use your divisibility rule. That's what we just reviewed. 1 plus 6 is 7. 7 is not a multiple of 3. There is nothing times 3 that gives you 7. You do not have divisibility. Anything times 4? Yep, 4 times 4. Now I'm not going to put 4 in my chart again. I'm just going to put it in there one time because I don't want to accidentally count it, right? So since I had a repeat there, I would be done. Look, compare between your 2 lists. What is the largest factor that they share? 4 would be the largest factor that they share. Therefore, it would be the GCF. So the greatest common factor, you're in that column, right? The greatest common factor would be 4. Let's use this same idea with 2 more pairs of numbers. We have 48 and 72. Let's start by listing the factors of 48. You can be using a calculator. So if you need to pause and go get that, please do so. Always starting with 1, right? 1 is a factor of every number. 1 times 48 gives me 48. So 1 and 48 are factors. Anything times 2, using my divisibility rules, this is an even number because 8 is an even digit. So yes, there is something times 2. If you're not sure, you can go 48 in your calculator and divide that by 2. What do you get? You get 24. Anything times 3? Yes, and if you're not sure, go 48 divided by 3. Do you get a whole number? If so, then 3 is a factor of 48. Thinking about my divisibility rules, 4 plus 8 is 12. 12 is a multiple of 3. We have divisibility. So I might need to use my calculator here. Maybe, maybe not. 48 divided by 3, that's going to give me 16. Anything times 4? You're not sure, go 48 divided by 4 in your calculator. Yes, 4 times 12, so 4 and 12 are factors. Anything times 5? Nope, this doesn't end in a 0 or a 5. I can see that right away. I don't even need to take time typing it in my calculator. Anything times 6. Yes, 6 times 8. And right away I can see that looking at my chart. I have a 2 and a 3 on here. A number is divisible by 6 if it's even, so it has to be divisible by 2 and divisible by 3. So since I saw both 2 and 3 on here, I know 6 is also a factor. Anything times 7. Nope, there's nothing times 7. Anything times 8. Yeah, repeat. What does that mean? We're done. All right, let's list the factors of 72 now. I know 1 times 72 gives me 72, so they are both factors. Anything times 2? Yep, because it ends with an even digit. So I might want to pull my calculator out and go 72 divided by 2. And I'm going to see that that is going to give me 36. Anything times 3? You're not sure, just look. Use your divisibility rules. 7 plus 2 is 9. 9 is a multiple of 3. Then we have divisibility. 3 times 24. And if you're not sure, what you do is in your calculator, you go 72 and divide it by 3. That's going to give you 24. Anything times 4. Now you may not know. Like, gosh, I don't know. Use your calculator. Go 72 divided by 4. What do you get? 18. So 72 is divisible by 4. Anything times 5? Nope, doesn't end with a 0 or a 5. Anything times 6? Well, do you see both 2 and 3 on here? Then that means 6 is a factor. If you're not sure what times 6 is 72, in your calculator go 72 and divide it by 6. What do you see? 12. Anything times 7? If you're not sure, go 72 divided by 7. I know there's nothing times 7. That's a whole number that's going to give me 72. Anything times 8? Yes, 8 times 9. So take a moment to look at the two lists. What is the greatest factor that 48 and 72 share? Our GCF for 48 and 72 would be 24. That is the biggest factor that those two numbers share. Now, you do the last pair. You find the GCF. Come back and check your answer with mine. Just in case you forgot to write the pair down, I will give that to you now. Pause the video, list those factors, and find the greatest one that they have in common. You can see my work here. Make sure it is similar to yours. And I got the largest factor for 35 and 63 to be 7. All right, y'all, it's time to write that summary. Divisibility rules help to determine if a number can be divided by another and result in a whole number. The rules are helpful when working to find the GCF of 2 or more numbers. The rules are helpful in determining if a number is a factor.